how a simple non-inverting configuration of an amplifier is connected is as per the question we have seen there. So you can see here this is a non-inverting amplifier where a 1 volt is being provided to the non-inverting terminal, and the output will be in phase with the input, and there is a feedback resistor, the RF, which is 1K, and another resistor to ground at the inverting terminal, which is 1K. So these are the resistors that are connected to the inverting terminal, which determine the gain of this particular op amp. So the gain of this op amp for a non-inverting configuration is given by RF plus R1 by R1. That means 1K plus 1K, 2K by 1K, which gives a value of 2. The gain is 2 here. So now V out is equal to the gain into the input. So that means input is 1, the gain is 2, so the output would be 2 volts. This is the straight away we determine. There is another way we can determine this output, but we come in reverse. So an op amp works in such a way that the output shall be created such that this Vd equals to 0. So because this is 1 volt here, here also it should be 1 volt such that Vd becomes 0. So here for the voltage to be 1 volt, because these two are resistive dividers and equal, so which is a 50% of the voltage here. That means if the voltage is 1 here, the voltage should be 2 here. So which says that if we calculate using the formula, or if we calculate using the simple scenario, the output will be the same. So if you see here, it will be 2 volts here. So and the formula we use is RF plus R1 by R1. Now just we will try to run the DC analysis to calculate the results here. So as we are saying, this will be 1 volt because that's how the op amp operates. Here the input is 1 volt. So you can see here this is highlighted in red here, and when you see here this is 2 volts. So there is one more circuit which is provided there, where there is 1 volt, there is a 1K resistor, and then the output is connected to this 1K resistor series, and then there is another 1K resistor which is connected to this. So basically it's like a resistor divider from the output is connected to this. Okay. So here you see that the bias voltage that is provided to this op amp is 6 volts. So now in this scenario, if you calculate theoretically in the similar way which we did previously. So before that, let us do a DC analysis. So you can see here this should be 1 volt, but it is 784.72. We will see why that difference has come. And here the output is around 3.92, and if you see the output here would be 1.57. So as we discussed in the previous scenario, if the output the op amp will operate in such a way that the difference between these two Vd will be 0, but here if you see there is a 784.7, that means there is some deviation from the voltage. So this is due to the offset voltage and basically the biasing of this op amp. So if you change this bias, this will vary further, but you can adjust this bias voltage to get the actual voltage. So if you theoretically determine how what is the voltage here, because this is 1 volt, this will be 1 volt here. As this is 1 volt, definitely this node, whatever we are highlighting here, should be 2 volts as per the previous calculation. If this is 2 volts here, because this is 1K and this is 1K, this should be 4 volts. So but this is 3.92. Now here you can see if you vary the bias voltage, you get a different value. you can see here. So this is how a simple non-inverting configuration works. So one has to remember as a designer that ideally the VD should be 0. If there is a deviation from this VD, or there is one terminology which we have used here called the offset voltage. If the offset voltage is not minimized, then you will get a difference in the output. So please give your comments or questions in this video, and let us know if you want to know anything. Thanks for watching.